each pair are similar. Find the scale factor of the smaller figure to the larger figure. Bless you. So we need to make sure that we are going from the smaller figure to the larger figure. Okay, so let's take a look at this. There's a couple of different ways that we can express the scale factor from the small figure to the large figure. First of all, we need to make sure we know which sides are corresponding. So, the 3 sides are the smaller sides, so they correspond to the 9 sides. That means the 4 side corresponds to the 12. Now, since we know that they're similar, we know that the scale factor is going to be the same as long as we use corresponding sides. So we can pick 3 to 9, or we can pick 4 to 12. We are going from the smaller figure to the larger figure. So if we wanted to write it as a ratio, we would say 3 to 9. We need to reduce that. We could reduce it by putting it in our calculator as a fraction, hitting math, enter, enter, and then rewriting it as a ratio. So when we simplify this, we are going to get what? 1, 2, 3. 1, 2, 3. So 1 colon 3. Now, if we're asked to write it as a fraction, we have to look at this a little differently. We are going from 3 to 9. We need to know, what do I need to multiply 3 by to get 9? So that x is representing what fraction I need to multiply the small one by to get the large one. So if I solve for x, 9 divided by 3 is 3, or 3 over 1. So be careful. If it asks for how to multiply it, so this is the ratio, small to large. This is the multiplier, small to large. So be careful about what the problem asks you. Think about it. If you're writing the ratio from small to large, the smaller number needs to be on the left. If you're writing a multiplier, in order to get from a smaller number to a bigger number, you're going to have a number that's greater than 1, or else it's not going to grow. So you got to think through that one logically. Okay, for problem 61, we need to make sure we know what's matching up. So the 9 side matches up with the 6 side. The 12 sides match up with the 18 side. So I circled the 18 first. Now I'm circling the 12 to show that they match up. Long matches with long. Small matches with small. So once again, we want to find our ratio. So we're going 6 to 9 because it's small to large. When we reduce that, what do we get? What? That's right. It reduces to 2 to 3. So that's our ratio. Now, if we wanted our multiplier, our small figure starts out at 6. That corresponding side is 9 in the large figure. So we need to figure out, what do I multiply 6 by to get 9? Now I solve for my multiplier. When I reduce this, x is going to be 3 over 2. So my multiplier, my small to large multiplier, is 3 over 2. My small to large ratio is 2 to 3. For problems 62 and 63, the polygons in each pair are similar. Find the missing side length. So when we have similar polygons, we know that we can set up what to find a missing side length? A proportion. So we need to make sure we know what corresponds with what. The question mark is going to correspond with what side? 12. Question mark is my longer side. So that means 5 is going to correspond to 10. Very good. So let's set up our proportion. We've got question mark compares to 12, just as 5, I had to go back to my original figure, compares to 10. How do we solve a proportion?
Cross multiply.
Very good. So we have 5 times 12 is equal to 10 question marks. What is 5 times 12?
60.
60. So 10 question marks equals 60, which means question mark equals 6. Question mark equals 6. Okay, for problem 63, question mark is going to correspond to what? 15. Thank you. Thank you. Now, we have this side labeled as 8 in one of our problems, but we don't have that same side labeled in the other problem. So that's not going to help us. We're going to have to use the 4, and the 4 corresponds to what?
12.
12. The 4 corresponds to the 12. So let's set up a proportion. We know that question mark corresponds to 15, just like 4, going back to the one that we started with on top, corresponds to 12. You already told me that in order to solve a proportion, we do what?
Cross multiply.
Cross multiply. So 15 times 4 is equal to 12 question marks. What is 15 times 4?
60.
60, which is 12 question marks. So we have to divide both sides by 12. So question mark equals
5.
5.
Over.
Problems 64 and 65 ask us to solve for x, and it tells us that the polygons in each pair are in fact similar. So once again, when we have similar polygons, we set up a what? Proportion. So we have to solve for x, so we have to use the side that includes x. So x minus 2 is going to correspond to what? 9. So I'm going to say x minus 2 corresponds to 9. Now, I have other sides labeled. I could say that 7 corresponds to 10.5. Or I could say that 16 corresponds to 24. I would prefer to avoid decimals if I can. So I'm going to go with the 16 to 24. Now I put the x minus 2 on top, so I have to put the 16 on top, which means the 24 goes underneath it. We know that we solve a proportion by doing what? Cross multiplying. So I've got 9 times 16 is equal to 24 times the quantity, x minus 2. When I have a number times something inside of a parentheses, what do I have to do? Distribute. So 24x minus 24 times 2 is 48. Is equal to 9 times 16. What is 9 times 16? 144. What do I have to do next? I have to add 48. So 24x equals 192. Now I divide both sides of the equation by 24. So x equals 8. Very good. X equals 8. All right, for number 65, once again, I have to use the section that includes x. So 3x plus 10 is going to correspond to 48. Okay, so let's set up a proportion. We've got 3x plus 10 corresponds to 48. Okay, now 18 compares to 15. We also have 18 and 15, so it doesn't really matter. They're the same. So we've got to go back to the 3x plus 10 figure, put that on top, so that's a 15. So we're going to put 15 over 18. So now we're going to cross multiply, obviously. So 15 times 48 is going to equal 18 times 3x plus 10 chord. So now we have to distribute. 18 times 3x is what? What is 18 times 3?
18 times 3 is 54x.
54x plus 18 times 10 is 180 equals, what's 15 times 48?
15 times 48 equals 720. 720.
Okay, now we have to subtract 180.
From 720, which is...
So I get 54x equals, divide both sides by 54,
equals 10.
x equals 10. Very good. X equals 10.
Good job.
Now, for the next section, we are asked to state if the triangles in each pair are similar. If so, state how you know they are similar and complete the similarity statement. So, we need to list our similarity conjectures. We have side, 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 similarity. What else do we have? Angle, angle similarity. And lastly, we have side, angle, side similarity. For problem 66, what kinds of angles do we need to label? We have vertical angles here, and vertical angles are always congruent. So, if we have the vertical angles marked, and we have two pairs of corresponding sides, what conjecture are we going to use for problem 66? Side angle, side similarity. So now we need to test it and see if the two triangles in 66 are in fact similar. So we've got side, angle, side. So the first thing we have to do is label our small side. So our small side in the top triangle is going to be the 63, meaning 91 is our large. Down at the bottom, our small is 45, so our large is 65. So now let's get our ratios. So 63 divided by 45 reduces to what? 63 over 45 reduces to what?
Oh, let me do it. 53 over 45.
1.4.
Take me out of SoundCloud.
7 over 5. Now, let's try the other ratio. So we have 91 compared to 65. What does that reduce to? 7 over 5. So our sides are, in fact, similar. Now we have to check the angle. We know they're vertical angles, so we know they have to be congruent. Since